Alright guys, gonna help cover a little bit of elimination some more. So 6.2 part 2. We're still sticking with solving systems by elimination. Guys, there maybe was some confusion on, like, when we said, we need to make opposite terms and multiplying to make opposite terms. So I want to take a minute here to explain, because those numbers that we multiply, they don't just come out of nowhere, but to explain the reasoning behind things. And I know Mr. Levarchik's talked about the least common multiple of numbers, the LCM. Okay, so if you're looking at two numbers, 7 and 4, okay, the least common multiple of those two numbers, and of course I know this off the top of my head, is 28, okay? You guys don't know that off of the top of your head, likely, okay? Some people might that are real good and comfortable with numbers and multiplying, but most of us probably don't know that 28 is the least common multiple of 7 and 4, okay? Well, how do I get that? So 7, okay, if I multiplied it by 1, it would give me 7. If I multiplied it by 2, it would give me 14. By 3, it would give me 21. And by 4, it's going to give me 28. If I went through the same exercise with 4, I multiplied it by 1, I would get 4. 2, I would get 8. 3, I would get 12. 4, I would get 16. And so on until I got to 4 times 7. And that would give me 28. Okay? And so that is the smallest number that 7 and 4 both multiply to. It's the smallest number that's common multiple of 7 and 4. Okay? You don't have to do this exercise every time. Okay? And so, like, why? Let me show you why a least common multiple of 7 and 4 would be useful. Actually, before I try and help out solving this one, let's look at an example of a system where, hey, that's useful. Okay, so the system of equations here, let's go negative 4x plus 6y equals negative 16. And let's go 7x minus 5y equals 17. Okay? So that whole thing with creating opposites, guys, I look at 4 and 7 and I'm like, those aren't opposites. They have opposite signs, but they're not going to cancel. They're not going to eliminate like I want. Same with 6 and 5. And I could do this exercise with 6 and 5, finding the least common multiple, but I've already done it with 7 and 4. So let's look. If I take this top equation and I'm going to multiply it by 7, that's going to give me, right, small over here, that's going to give me negative 28x plus 7 and 6, that's 42y. And guys, we're not going to solve this whole system. The numbers are going to get pretty big. In fact, I need a calculator here. Let me grab one. What is 7 times 16? Don't know it off the top of my head here. 7 and 16 make 112. And that should be negative 112. Okay? If I do that same idea with least common multiple, hey, if I'm making that a 28x and a negative 20y equals 4 and 17, what would have 34, 68. Okay, now we have opposites. We created opposites using least common multiple. Okay, so that idea of least common multiple, that's very useful for systems of equations. All right. Let me show you another example of least common multiple, like where it might be something useful for us. I want to find a good one here, guys. maybe where it's a little different. I'm just looking at my system, sorry guys. Looking at my sets of examples here. Okay, so how about 4 and 2? 4 and 2. Okay. This one's a pretty simple one, but it highlights what I want it to do. Okay, so 4 and 2. Looking for the least common multiple. It's actually going to be 4. Okay? You think about 4 times 1 is 4. 2 times 2 is 4. So that's the least common multiple, is 4. How that applies in an example is, well, what if I had negative x plus 4y equals 4, and I had negative 3x minus 2y equals 12. And I wanted to solve, and I wanted to, maybe I wanted to eliminate these y's. Well, just multiply the bottom by 2. Okay, I don't need to multiply the top by 1 to make that 4, because it's already 4. So if I multiply that bottom equation by 2, I get negative 6x minus 4y equals 12. And that top equation, again, wouldn't need to change, because the least common multiple was 4. So now there we have opposites. And of course, guys, I'm not solving these systems all the way. I didn't want to take too much of your time today. I want you guys a chance maybe to catch up on getting some assignments done. I know we have some missing building up. So if you guys need more refreshers on where do I go once I have opposites, guys, of course you can look at the first elimination video I made on Friday. So hopefully you found this helpful. I'm going to have some least common multiple questions on your assignment for today. I'll probably throw a couple more elimination problems on there as well. So just a little bit of practice today. Hope you guys had a good weekend. I know I won't get to see you guys this week, so make sure you continue working hard on this e-learning. Thanks, guys.